10 to go. Hey everyone, thanks for joining our webinar today. We'll get started in about 2 minutes. We'll just wait for everyone to start filing in and make sure everybody can load Big Marker okay. So just bear with us for 1 or 2 more minutes. Hello to everyone who's still joining. We're just waiting for a minute or so for everybody to finish filing in. So sit tight and we'll get started shortly. Hey, welcome to everybody who's still joining. We're just going to wait about a minute for everybody to finish joining the webinar. So hang with us and we'll get started soon. All right, I think we can get started. Hey everyone, thanks for joining us today. My name's Andre. I just want to mention some quick housekeeping items before we get started. First, this webinar is being recorded. The recording will be made available after the webinar ends. There will also be a follow-up email, which will give you a link to the on-demand recording once it's been processed by a webinar platform. We'll also have a short Q&A session after the presentation. So feel free to enter questions in the Q&A pane on the right side of your screen, and we'll answer them at the end. As always, we appreciate your feedback on our webinars, so please let us know how we did and if there's anything that we can do to improve. So again, thank you for joining us today on our talk, Automate Reliability in Your CI/CD Pipeline with Gremlin, How a Global Leader Ensures Reliable Releases. Before we get too deep into the content, I just want to start by posing a question. How do you automate reliability while maintaining high release velocity? Well, the title kind of answers that. You embed it into your CI/CD pipeline. But for most teams, this raises more questions. We know how to automate things like unit tests, integration tests, and other types of tests in the CI/CD pipeline. But how do you automate reliability tests? What types of tests do you run to validate reliability? How do you run them? And how do you enforce a standard of quality across multiple different teams who might be using the same pipeline? So in this webinar, we'll take a look at one team's model for integrating automated reliability. We'll see how Gremlin fits into this model, and then show you how one company took this idea and worked it into their pipeline to see success. So who are we exactly? Again, my name is Andre Newman. I'm a senior reliability specialist here at Gremlin. I'm joined by Dushyant Sani, global practice leader for horizontal tech and consulting at Nagarro, and Kaushal Dalvi, performance engineer practice lead at UKG. Kaushal and his team are responsible for implementing the reliability pipeline at UKG, while Dushyant and his team are the experts helping them achieve this goal. So quick look at our agenda for today. First, I'll start off by talking about where do reliability risks show up in our systems. Kaushal will take over and introduce UKG and what their goals were for this project. Dushyant will talk about how Nagarro worked with UKG to implement reliability testing. We'll go back to Kaushal, who will talk about their learnings and what the future looks like and what their plans are. And then I'll wrap up by talking about how Gremlin helps with this process and helps teams shift from reactive to proactive reliability work. So before we dig too deep into the how, I'd like to start by talking about reliability just as a concept as a whole. Why is reliability so important? Well, the answer is that modern systems, as I'm sure most of you are familiar with, are incredibly complex. Each bit of added complexity is a new place in the system where failures can occur, much like how software bugs emerge over time. This is what we call the minefield of reliability risks. These can include things like unknown or unmapped dependencies that could impact critical services, misconfigured autoscaling that doesn't kick in when needed, or scale back when we don't, driving unnecessary costs, missing or broken redundancies that have never been identified, untested resilience hacks, things like quick fixes and production fixes that haven't really been tested or designed for ongoing use. And then, of course, non compliant architecture that's not well documented or well understood. Now, these risks are just hiding in our systems, waiting to disrupt users' lives. And the problem is that our systems that we manage have become more complex than our mental models can handle and change more frequently than any one person or team can track. So, what are some of these different risks and where do they emerge? This is a simplified model, but just want to give you a general understanding of how these different stages can introduce different types of risks. For example, development adds things like new untested code or new untested dependencies. It's also a place where regressions can get introduced. Deployment is usually the step where code gets prepped for production, but even here we see introduce or risk being introduced, such as provisioning new infrastructure and environments for the code to run in. There are ways to mitigate these risks using techniques like infrastructure as code and standardized test environments, but they are still present. And then, even in production, teams need to consider that production is a unique environment. Customers might use the system in ways we didn't anticipate, leading to unexpected and undefined behaviors. There's also the risk of production drifting from other environments, which can lead to its own set of behaviors that aren't reproducible. This is why it's so important to run tests during the CI/CD process. Most teams already have a gauntlet of tests built into their pipelines for quality control, especially things like unit tests and regression tests. But what many teams are missing in this step are reliability tests. We have a lot of customers who want to automate reliability in CI/CD, but what many of them find is that this is a lot harder to do than they think. But fortunately, Kaushal and Dushyant have tackled this problem and come up with a solution that works for UKG, and are more than happy to share it with us. So now I'll pass it over to Kaushal to explain more.
Awesome. Thank you, Andre. Hey, everyone. My name is Kaushal Dalvi, and I lead the performance and resiliency enablement practice here at UKG. UKG is a recognized leading software as a service solution in the human capital management, workforce management space, serving thousands of customers, small and large, with millions of users across the globe, offering products in human resources, payroll, talent, scheduling, pretty much all things human resources. And this award-winning suite of products is, I believe, the reason the suite of products is so loved is because of our focus on all things quality. And I focus primarily on non-functional quality, specifically performance, where we focus on the utilization and latency and availability characteristics of the system under different types of load. And scalability, we ensure that the system is able to maintain those performance characteristics when the workload is growing. And the start of today's show, resiliency, where we also want to maintain and ensure that these performance characteristics are not affected when there are underlying failures. So we subject our systems to failures to see how it is going to react, and those performance characteristics are maintained. So how we try to achieve this as an enablement team, we work with different product teams in our org, and we have come up with a life cycle for ensuring this performance and resiliency. Starting with non-functional requirements, because that is really where the story begins. You need to know what you're designing for. And once you know that, your non-functional requirements at the product, feature, or story level, those need to be treated as features that they need to be designed for and built for with intent and purpose to build performance and resiliency into the system. The next logical step is to validate what you built, that were you able to achieve what you had set out to achieve from the performance and resiliency characteristics. But that is not enough, because you also need to make sure that you're seeing those results in the real world as well, that your customers are feeling the same thing too. And that's where real world monitoring comes in, where you tie back and correlate what you're seeing in the real world compared to the lab. Hopefully, soon we should also be able to do some of those tests in the real world in production as well with resiliency. And all of this is tied back together with a feedback loop of uh, whatever we have learned through this cycle, we feed it back into the rest of our process to keep making it better, to keep making improvements. All right, so we wanted to do this uh, especially for resiliency and mature our practice a little bit. So we thought that the next logical step is to bring it to the CI. So let me describe our journey for doing that a little bit. This is where we restarted and started working with both Gremlin and Nagaro. And our first step was to figure out what do we need to get started. We started by building out the prerequisite assets, for example, building out the right environments, having the test suites, defining SLIs, SLOs, things like that. From there, the first task was to do manual runs and to learn what we are getting back. What those initial tests showed us, it gave us valuable insights because we learned what's going to work manually and what needs to be different when we incorporate this in a CI pipeline. So the next step then was to optimize some of those processes and build the right tooling such that the resiliency tests can be run from a pipeline. And Gremlin's API first approach made it possible to do this in a very easy manner because everything that we could do from the UI and manually, we could replicate all of that through the API as well. So with the first few teams, we were able to implement all of the tests along with some of the tooling that we had built for our own stack and be able to get those tests running in the CI/CD pipelines. And our current state right now is to evaluate how that is going with the teams that are getting onboarded and also to provide maintenance and support to those teams as they keep improving their processes. So I'm gonna take a pause here. I'll come back later and talk about how that has been going and what are our plans for the future. But for now, I'll pass it on to Dushin to take us over Nagaro and their resiliency practice.
Oh, Dushyant, you're currently muted.
All right. Thank you, Kaushal. Thank you, Andre, for setting this up nicely. Before we dive into the topic, a quick snapshot about Nagaro and our work in the resilience engineering space. We are a leading digital engineering services company, which is providing an end-to-end service portfolio to build world-class resilient software products and applications. Our customers love us for our differentiated working ways that rely on friendships, collaboration, and transparency. Resilience engineering is our service to help organizations achieve that elusive 5 nines on their critical software and become more confident and assured about the software's design and its ability to just work, no matter what the situation is. So let's dive into the topic now. What has Nagaro really done? Nagaro has built a NREF framework, which is our North Star approach to achieve continuously high resiliency. We start by doing a discovery to learn more about the critical software's current state of reliability and resiliency. The idea is to understand and assess the readiness of the software to handle scale, and we do that through our assessment toolkits. So once we are clear about this, we put the software and its teams on an iterative and incremental journey of where we are trying to understand the observability, the state of observability, and with chaos engineering, which is our learning tech here, it plays a pivotal role. We find components where resiliency is imperative, test them, determine benchmarks, and make observations about metrics like MTTR, and then work with teams to continuously improve through well architected reference frameworks and modernization overall. So, to give an example, once we had tested a critical software that was doing millions of online transactions on a daily basis for its resiliency. The design was fail-safe. And design was fail-safe, providing redundancy on critical services by having multiple instances deployed on different VMs. What we did was we ran a virtual machine terminate test to bring down an instance of that service with the hypothesis that it will recover automatically. Well, the service did recover automatically, but the system saw a cascading failure. Now, what we learned is that the other services hosted on that same virtual machine didn't have enough redundancy to handle the transaction volume. So, this was something where the team got a chance to improve its overall design. Overall, we were proactively able to find a critical fault. We avoided a production incident that could have potentially led to a bad experience and losses. Now, you may say that we test such scenarios in DR drills, but I will ask how often. And your software releases are much more frequent, just like how Andre said. So, why not test this every time? And imagine doing this continuously. So, how do we achieve this high resiliency? Our approach here with the NREF is pretty enterprise grade. We think of scale readiness from day one and have a good idea of using chaos engineering to continuously improve the reliability and resiliency by designing tests and experiments that yield such powerful outcomes. So, how do we do it at enterprise scale now? We start with the dev environment. We enable engineers to perform basic reliability tests, example, the instance failures. As the complexity increases, we move towards the QA environments, where we test interdependency and look for cascading faults and enable teams to test holistically by making game days a habit. The ultimate goal is to test in production and basically come to a point where, to be honest, nothing should be a big deal. And the whole undisclosed game days or randomizations and automations help over there. So to prepare for production, we have in fact worked closely with cloud service providers to test complex scenarios like serverless. Our approach is to democratize these complex tests and make them available to feature teams. Every release can now go through an additional quality gate, a gate that tests resiliency. So with increasing repeatability of these tests, we increase confidence and assurance among stakeholders about the system's ability to deal with unwanted scenarios. We discover unknowns, make them knowns, and be ready so that nothing is a big deal. Now, you may want to know how we do this. We all know the natural CI/CD lifecycle. For continuous reliability, what we do is we do shift left and add a chaos stage to the pipeline. We have created this shift left accelerator package that has a reference pipeline. It integrates with load tests and Gremlin APIs to set up the test scenario. It's built on the principles of interoperability, showing impact of tests in an observability tool. It has these really cool probes that check the health of the system before, during, and after the test, completely automating that entire process through the resiliency toolkit. It reduces the time to embrace and adopt continuous reliability. And I'll let you see this in action now.
Your CI/CD pipelines. For the purpose of demo, we are using Bank of Anthos application that is a sample bank deployed on a Kubernetes cluster. It performs payments and deposits as in a normal bank. We are using Jenkins as a CI tool for the purpose of the demo, Grafana as the observability tool of choice, which is using Prometheus at the backend, and Gremlin as a fault injection tool of choice. Gremlin is one of the best tools available in market for injecting chaos, and we are using REST APIs from Gremlin in our Jenkins pipeline for this demo. Let's see how the demo works for your own build and release pipelines, which might have certain stages already working for them. We are now introducing an extra stage for running chaos even after you release it in the dev environment. Your product might want certain chaos test cases to run automatically to ensure reliability of your application. For the purpose of this demo, we are running a latency test which will inject latency of 625 milliseconds for a duration of 1 minute between our database and payment service. Let's first see how this works in your build and release pipeline. Your build and release pipeline might already have certain steps that include static code analysis, unit testing, build, and deploy stages. The new stage for chaos testing triggers an additional pipeline called chaos underscore test. As you can see, this pipeline triggers another pipeline which might have certain stages of its own as well. Let's go ahead and see what are those stages. The first stage is validate target, which lets you check whether the targets are even eligible for chaos or not. In your dev environments, you do not want to bring down any services that might cause a real chaos for every developer using the development system. So it is important that you assign labels so that you can validate whether you are chaos eligible target or not. It is also important to understand the steady state of the application before running chaos, and that is what the validate target stage does. In the next stage, we inject user load using JMeter so that we can see the impact on real-time users. At the same time, you can see we are triggering chaos workflow. This chaos workflow in turn calls Gremlin APIs, which inject a network latency experiment. After this stage, there is a collect observability metric stage, which helps you collect observability matrices from Grafana and present it to you. Finally, you again validate the steady state of the application by the means of probes or status checks. You might want to do necessary automation to check whether your systems have recovered back to their normal state or not. Now let's see how this performs on the Grafana dashboard. This template, as you see, can be reused for any payments application. As you can see, there are already 3 payments which have failed out of the 10 payments which were made during this period. This is currently breaching our SLO, which is 98% of the payment transactions must be successful. However, only 70% of the transactions are only successful, thereby exceeding our SLO and also proving that the experiment is proving the application to be unreliable in scenarios of latency greater than or equal to 625 milliseconds. Now let's go and try and check this scenario on the Gremlin UI as well. As you see in Gremlin, there is another scenario that is created at the backend which has been triggered via the API. This is the same scenario of 625 milliseconds and a latency of duration 1 minute. This is how you utilize Gremlin APIs to inject chaos via Jenkins or any CI tool of your choice in your ecosystem. Thank you.
So this setup that we just demonstrated becomes the quality gate, a great enabler and an accelerator to test resiliency continuously. Let's see now what more is required to consume this kind of automation to run reliability tests in production. Now I'm sharing some broad dimensions and variables to ensure readiness to test in production. The first and foremost, and the most critical one, is the people aspect. We really want a buy-in of all stakeholders because that's the most important step here. Then we move to the engineering dimensions. The first one here is the choice and readiness of the test. We don't have to experiment in production, we have to test in production. That's the key. The next dimension is the timing. When do you run these tests? During non-peak hours or during any time of the day? You don't want to start by any time of the day, and that's the variability that you have to control. You may have selected the test to run, but what are the components you want to test? So complexity now becomes a key variable. More complexity definitely leads to a higher confidence. So this is a important decision point, but there has to be a method in making this decision. No one wants to mess in production. So to continuously check the health of the system, we need baselining of critical vitals. We're talking about SLIs, SLOs, the error budgets. The health probes here become extremely important, and observability readiness is extremely critical too. Lastly, your prep for that nothing is a big deal event. One should also proactively prepare to handle unknown unknowns. We don't know what we don't know, so our strategies to handle those situations are also critical. Now, lastly, while chaos engineering is giving us the insights about our system, what we really have to do is, after learning those insights, we have to complete the loop. We have to act on it. We have to improve the system's design so that it reaches that new state of continuous, highly resilient system. And to evolve this design and to handle newer challenges, on the screen, we are showing a few guiding principles that our experts have curated to design well architected software. And from that point onwards, that journey of build, measure, learn continuously kicks in. And that's how you continue to achieve higher reliability consistently. So back to Kaushal now.
Thank you, Dushyant. So earlier I had teased that that was the point that we had reached where we are enabling teams right now. But to be super honest, software engineering is dealing with trade-offs. We all have different priorities that are coming up. And that's not just the case with UKG, that is the case with absolutely everyone in the industry that I've spoken with. How do we manage performance, scalability, resiliency, the non-functional aspects? So we ran into similar things as well while we were trying to optimize this process. The fact that resiliency engineering or chaos engineering being a relatively young field, right, in comparison to computer science as a whole, there aren't as many subject matter experts to include resiliency practices in the development life cycles on the actual product feature teams themselves. And the product teams and the feature teams are dealing with their own time and priority issues. There's always going to be a push for getting more features out to be able to differentiate yourself from your competitors. So one could think that, one way around this, maybe just add more people, add more headcount. But that's not going to be a super practical or efficient solution. So we had a thought, an idea, which felt like a moonshot project. But before I talk about it in the resiliency space, I want to talk about it in the performance space, where we feel that we have been able to make significant progress and pretty much solve it for UKG. Where what we did for performance testing was, one of the concerns was, again, not having SMEs. So we built a system that could build performance test assets for you. We call it tag performance test asset generator. You provide it a Selenium script. It does all the necessary work to give you a performance test script. And because of that, regression now happens automatically. Performance regression, I mean. And we've made it to be CI friendly as well. So now you also don't need human intervention to keep kicking off your performance tests. We've made it self-serve for all the feature and product development teams so that they can use it as they need it. We have some future plans there as well. I'll not get into that. For now, the other aspect of performance, which was an issue that needed to be resolved, was just the complexity and boilerplate work that you end up keep doing over and over again. So we built another system, we call it Trigger, that does things like, it abstracts away all the things that you need to do, like setting up your load generation, making sure that it is consistent, capturing all of your results, doing historical trending around it, doing SLO validations for your test to see whether you've passed or failed, providing notifications based on that to let either your pipeline know, or Slack or Teams or email, and to host these test results as well if someone wants to go back and analyze what had happened. So what we saw from this was, earlier there was a dedicated performance testing team, but after making this available to everyone, we had thousands of tests conducted by product and feature teams that did not have dedicated performance test engineers. They were able to do this independently. So what we thought was, let's bring this mindset to resiliency engineering as well. And again, do the same thing, abstract away the complexities and the boilerplate work that is involved, with the goal being that we want to empower teams such that they can do it on themselves with minimal investment. So what does that future look like? So we have started working on and pretty much finished the first step of it, which is the automated setup, where a product or a feature team just brings their environment and provides us the servers or containers or wherever they're deployed, their stack in either JSON or YAML format, and we are able to go in and set up Gremlin agents on them. From that point on, another area was we would wait for subject matter experts to figure out what should be the resiliency plan, what should be the resiliency test. So we want to build a recommendation engine where once you provide, this is what your setup looks like. We could do things like see, oh, I see you have a Mongo with a 3-node cluster. From previous patterns, we have seen that there could be issues here. So we recommend that you do a black hole attack where you take away your primary and see what happens with your election. And then we want to do the full end-to-end orchestration along with setting up the environment, setting up the performance tests. And again, Gremlin's APIs make it super easy to set up your attacks, scenarios, and experiments and invoke them at the right time. And finally, we want to build up that knowledge in the product and feature teams. Gremlin already has a ton of great documentation, but we intend to build UKG-specific learning and training content that is scalable so that teams can make better use of this. All right, I'm going to throw it back to Andre now to bring us home.
Awesome. Thank you, Kaushal. So before I actually get started, we had a few really good questions come in, and there's one that in specific that I want to answer. First is, what is chaos and how is it helping? So chaos engineering, for anyone who isn't familiar, it's a practice of testing the reliability or resiliency of your systems by injecting failure. This means recreating failure conditions like network outages, high latency, high resource usage, or failed processes. And the reason this is important is because the only way we can build resilience to failures is by testing our systems against those failures. And chaos engineering is a controlled way of doing that. So with Gremlin, what you can do is you can, for example, add network latency to your systems, tie Gremlin to your observability tools, and use your observability tool to see how your systems react to that latency, and then immediately roll back the latency so your systems go back to normal. So that's what we mean by chaos, and that's how that works into that whole process. So great question. I just want to make sure I answered that before continuing. So basically, the goal of all this work is pretty straightforward. We want to help teams move away from doing reactive reliability work to doing more proactive reliability work. This means helping teams go from responding to issues to focusing on high impact activities. So instead of having production incidents that they have to suddenly jump up or get up in the middle of the night to respond to, we want to help teams find those reliability risks before they end up even hitting production. So this way, engineers can focus their efforts on where it has the biggest impact, which is, of course, developing products, building features, and scaling services. This also shifts a lot of the reliability work that teams do from guesswork to real measurable progress. You can test services against specific risks, validate your fixes, and show that your work is having an impact. So if, for example, you might have the question, do you know how many reliability risks your team has prevented in the past week or the past month or the past quarter? That's the kind of question we want to help answer. And most importantly, we want to help teams move from manual and ad hoc reliability practices to ones that are built in and automated. Asking engineers to do more work and add more reliability tests to their day-to-day isn't scalable. Companies like UKG know this, which is why the focus is on automation and standardization. So imagine being able to measure and improve availability on hundreds or thousands of services across all your engineering teams without having to pull resources away from development. That's the ultimate goal of this, and that's the priority that we try to help out with automating these reliability tests. And there's also one more point that I'd just like to reiterate that was brought up earlier. A question we often get, I think we actually have a question right now in the Q&A about this, is where should we test? Where should we run these tests in staging or production or both? So understandably, a lot of teams are concerned about running reliability tests in production, especially given the nature of chaos engineering. So I just want to go over the differences between them. So in staging, and by staging, I really mean any pre-production environment, the benefit is that you're effectively isolated from your live environment. So you can run these tests and the risk of impacting users is basically zero. This means you can test however you like, and if something goes wrong, you can just roll back or start over completely. The downside, though, is that staging is inherently different from production. It behaves differently, it responds differently. So the tests that you run there might not give you a completely accurate view of the real world. This also means that any improvements you make might not directly benefit your users. You have to make the improvements to staging, then migrate those fixes to production and hope that the same issues get resolved. And again, because staging is different, not everything you learn will translate over to production. Fixing an issue and deploying it could change production in ways you didn't expect because it's a unique environment. Now, in production, tests will give you real results, and fixing any issues that you find there will benefit customers directly. The risk, of course, being that it's production. If you do something like accidentally bring a system offline during the testing, there is the potential that you impact customers. That's why it's important to have a tool like Gremlin that lets you safely test and roll back test immediately. And we actually have a feature that we built in called health checks that integrates with the observability tool and actively watches for undesired behavior. But in addition to that, we also have a big red halt button that's right in our web user interface that you can click to instantly stop running all tests. Safety and recoverability are really important, not just to us, but to our customers. We hear them ask us about it all the time. So we try to make it as easy as possible to do this type of testing safely. This is built into our automated testing processes as well. So while you're running experiments during your CI/CD pipeline, you can immediately stop and fall back if needed, using those health checks, using our API, or by logging in and hitting that big red halt button that I mentioned earlier. And so before we jump over to Q&A, I just want to have a few more things I wanted to cover. If you are ready to start your reliability journey, or if you'd like to learn more, we have a few different ways that you can get started. First, if you're interested in trying Gremlin, you can sign up for a 30-day free trial by going to gremlin.com/trial. We also have reliability experts who are more than happy to give you a live demo of Gremlin and to talk with you about your reliability needs. So if you would like to talk to them, you can head over to gremlin.com/demo to get in touch. You can also evaluate your organization's resiliency maturity with a free 3-day workshop from Nagarro by heading to go.nagarro.com/resilience-engineering, #register now. This gets you a free consultation by their resiliency engineering experts, so definitely check that out. In the meantime, thanks so much for joining us today. We'll continue with live Q&A. So again, if you have questions, please enter them into the Q&A pane, and I will field them to the rest of the team. And I see we have a bunch here already, so let's see. So here's a question for Kaushal. Do you have any trouble getting teams to agree to try chaos engineering tests?
Great question. I think I'll refer back to where I started my second half of the presentation, that everyone has their own priorities that they're dealing with. So given unlimited time and money, absolutely everyone would want to build the best possible system that is the most secure, performant, resilient, and everything. So then the question comes down to the priorities and the resources they have. So yes, there's always that back and forth of the amount of bandwidth teams have available to take on resiliency. But making it easier, if you have such a setup in your organization where you have enablement teams that can do some of the common tasks that make it easier for teams to adopt. That has what has worked well in our case, and also uh, just knowing. I think Dushyant called it out at the beginning that you have to make the value of this known and get buy-in from an organization level, because the investment that you're going to make here, it's not going to be a leading indicator. The indicator is going to lag a little bit, but it will show in the results of your outage costs going down. So a combination of all of these things from a people level to a technical level is what I use to move the needle forward with teams.
All right, awesome. So we have a question here for Dushyant. How do teams react when you do game days? Do they find them helpful?
Certainly do. Teams really find those game days helpful because the number one reason is that not everyone is acclimatized to be a part of these reliability tests. But the important factor here is that reliability is kind of a team game. It's not just the it's not just the reliability team or resiliency practices responsibility, but there are other folks who have to come in. So there is an aspect of the incident response team, there is an aspect of the SRE, there is an aspect of the feature team itself that has to be party to all of this. And what they learn as part of that exercise is something which sort of helps them to sort of do this more and more. So the discoveries are very important. And the second bit, what the teams really enjoy about this is that it's kind of democratizing the knowledge about the system. One of the purposes of uh, chaos engineering or reliability testing, for that matter, is that you democratize this knowledge of the system amongst other team members. There shouldn't be scenarios where if there is a bug that happens, and there is a hero culture that only this person can fix this bug. That shouldn't happen. That knowledge should be with everyone within the team, and that's what teams figure out when they are doing these game days. And the third one is that uh, I go back to the first point, which was about the discoveries. So one is that you are gaining the confidence that your test is behaving as expected, which is how you design the system to respond in a certain situation. But the discovery aspect of it, which is the unknowns, if you add variables like randomizing, or if you don't tell the team what type of tests you're going to do, the behaviors suddenly change. And those are some of the things that the teams have to learn, so that they are ready to prepare for nothing is a big deal kind of a event as well. So yeah, that's how I would put it.
Awesome, thanks. So we have a question: what all categories of reliability does Gremlin address? So we cover three main categories of different chaos experiments: resource experiments, state experiments, and network experiments. Resource is exactly what it sounds like. It's for consuming CPU, memory, as well as putting pressure on storage devices. So you can create disk IO as well as filling disk. With state, you can shut down or reboot a system, very similar to Chaos Monkey if you're familiar with that. You can change the system's host time, which is useful for testing time-based events. You can also terminate processes. And for network experiments, you can drop network traffic, what we call a black hole, add latency, add packet loss, and also check for expiring TLS certificates. You can learn all about that on our documentation website if you head to that at docs.gremlin.com. And if you have specific questions about a certain type of reliability test, we have blog posts, tutorials, white papers that go into detail on all of those. So again, I recommend going to docs.gremlin.com. You'll find all your answers there. So maybe this is one that I'll forward to you, Dushyant. And if this isn't one that you want to answer, that's totally fine. But what scale or tier of application should Gremlin be implemented in? And how do you avoid over engineering?
So from a scale perspective, I think the moment the the organization's business is at a point where they are expecting that scale is imminent, whether it with be with respect to say a payments scenario, or whether it be with respect to an API that's going to be accessible to multiple other third party organizations, and they're ready to handle that scale. That's where I feel that they should start considering the reliability testing, and Gremlin, of course, can handle that scale pretty well. We've already tested it with, I guess, uh, thousands of concurrent transactions with the load coming in the UKG scenario, and there is, of course, more that can be done. So that would be my response.
Okay, perfect. And I know we're running short on time, so we'll just do one last question. How do you make chaos a habit at the organization level, and how do you identify which scenarios to run?
So, I think which scenarios to run is something one has to look at that cycle of measure, learn, build that we were describing earlier. You can't be testing reliability if you haven't really built for it, or you can't be testing resiliency if you haven't factored that in your system design. So the first go to place is that you find out those patterns that you have implemented within your software so that you can test it accordingly. If you haven't even implemented those, then it's a no starter, I would say. You need to first build in those things and then start testing. So that's the scenario identification. And to make it a habit, I guess the model that we described, where you are injecting it into the pipeline, is definitely one way of democratizing it. The model that we've seen work is that typically there is like a central COE type of a team which is incubating the whole different test scenarios that could be possible for a given setup, and that's something that uh, is implemented in UKG as well. And once you have that setup available, then the teams have to start adopting that, and you take it one after one by one. And you don't really do too many things at once. So the adoption has to happen incrementally. And once everyone starts to see the value, that's where they automatically believe in the benefit of it.
Ooh, and I have a thought here as well, but before I proceed, could you please repeat the question one more time, Andre? I want to make sure that I'm answering the right thing and not what's in my mind.
Yeah. So, how do you make chaos engineering a habit at the organization level, and how do you identify which scenarios to run?
Yep, I'll answer the second part because it's a little closer to my heart right now, which is how do you choose? That's where I'd spoken about, and this is very biased. This is where I am at right now. I'm not saying that this is what is going to work for everyone, but how we approached the problem was looking at what is your possible inventory that you could be bringing to the table. What are the different types of uh, storage solutions, database solutions, or tech stacks that you could be bringing, and what could be the potential issues that are known to happen for these types of systems. The example that I'd given was you bring a Mongo 3-node cluster, you know that things can happen with elections. If nodes lose connectivity because of, that's where you could select a black hole attack or a state attack to bring down. So one is you could create all the list of that inventory of, for these types of systems, these are known things that can happen, and this is how I use an attack to emulate that. Other is you go back to what you have seen in your own experience in the past from your outages over the last few months or years and see that, oh, we are prone to run into these types of things. So how can I make sure that these become one of the top things that I look forward to recommend when running a new attack? That's our approach right now to building that recommendation engine of what attacks to run.
Perfect. Thank you for that. So we are at the end of our Q&A session. There were a lot of great questions here, though, so we'll make sure that we record these and follow up with the folks who asked them. If you do think of questions afterwards, you can always reach out to us directly at gremlin.com or nagaro.com, and we'll make sure to get back to you as well. One last thing I would just like to cover quickly before we wrap up today. We do have a few really cool, exciting Gremlin features that are coming up that I just wanted to share with you. So first is detected risks. Right now, our agent lets you run fault injection tests on your systems, but soon it will start finding and reporting potential reliability risks as soon as you deploy it to your systems. We're starting out with a focus on Kubernetes, so you get configurations on how to make your deployments more scalable, more resilient to failures, and how to add redundancies. Next is a feature called failure flags. If you're familiar with feature flags, this is the same concept, only with reliability tests in place of features. You'll be able to inject latency, exceptions, and other types of failure into applications and serverless functions to be able to test things like connections to database, connections to dependencies, and also AWS Lambda and other serverless functions. We currently offer a form of reliability scoring, but in the future, you'll be able to define custom reliability scores. We recognize not everybody uses the same criteria for measuring and tracking reliability. So we want to give teams the ability to tell us what they define as reliable. So as an example, Kaushal can go to his team. They can define what's important for them for reliability and use that as that criteria. And then last is just easier onboarding. You want to make it effortless for teams to be able to add services and their health checks and their systems to Gremlin so you can start running tests faster. So in the meantime, that will do it for our webinar today. As I mentioned, there will be a recording of this webinar made available afterwards. You should receive it automatically via email. You will also, we'll also forward the unasked questions to our team and make sure to get those responses back to you. In the meantime, thank you so much for joining today. Hope this webinar was helpful for you. Just want to say thanks again to Dushyant and Kaushal for spending their time here and sharing their knowledge and experience with us. Thank you all for joining, and that will do it for our webinar today. Thanks again, and have a great day.
Thank you.